Welcome back, Algebra Half. Today's lesson, lesson 61, is called Solving Equations in Two Steps. We've solved equations in one. Let's try solving them in two. I just think this is where algebra starts to get even more fun, where it gets a little more involved and you have to think just a little bit more. And it's not just follow the same pattern, although there is a lot of pattern to this. You have to just put a little bit more to it. We know in one step that x over 3 equals 2 is solved with one step. It's that we need to multiply both sides by 3 so as to find out that x is 6, right? So let's try making that a second step now. What if we have 3x and there's a 2 on there equaling, let's say, 7? Now what do? I can't just multiply by a third like we would normally do. I still have this over here. And you're not going to want to do that division first, because if I divide both sides by 3, I have to divide the whole side by 3. Now I've got x plus 2/3 equals 7/3. And it's just not as pretty as I'd like it to be. I'm not going to start with my multiplication or division, nor will I normally. First, I'm going to look to eliminate any added or subtracted constants from the variable side. Got that? Eliminate any added or subtracted constants from the variable side. This is the variable. Let's get rid of the added constant. And to subtract 2 from one side, I have to subtract 2 from the other. Now, I don't have to try to subtract 2 from this. I just subtract 2 from here, and that's legal. And here. So I can write 3x. That's a lot prettier than what I had before by trying to start with division. 7 minus 2 is 5. Now, I can do what I normally do. This is a one-step problem I'm familiar with that I divide by 3, and x is 5/3. Okay, kind of makes sense. Let's try it again. If I just had, one second. If I just had, let's try red now. 2 over 3x equals 10. That'd be a one-step problem. How do I solve? That's a time sign. Times both sides by reciprocal of the coefficient to the variable. Right? You just sort of sense that pattern. We've done it so many times. Get rid of these. X is, well, 30 over 2 is 15. Okay? But let's complicate this now into a second step. Make it a little more exciting, a little more spicy. Let's try 2/3 x like we had. Let's have it equaling 10. But what else could I do to add a step? I could add or subtract. Let's, from the variable side, to make it a little bit more, let's subtract a fraction. 2/3 x minus a half equals 10. Well, I don't want to start with this, because then I have to multiply it by this too. And it's just more than we need to do. Let's add 1/2 to both sides, so that I have 2/3 x equals, and when you're adding and subtracting fractions, this really ends up becoming a horizontal solution. 10 over 1 equals 1 over 2, which in your papers you'll probably immediately write 20 over 2 plus 1 over 2 is 21/2. That's 10 plus the half from the left, the variable side. Now let's finish. 2/3 x equals 21 over 2. What do I do to solve this? I multiply by the reciprocal of the coefficient like I always have. No canceling that I can do on the right, so it's x equals 63 over 4. All right, last one. Remember, these are solving just like we've done before, but we're just adding one extra step. solving in 2 steps. I'm going to try example 61.3. It's got a lot to it. See if we can run through this. 2 1/3 x minus 1 1/5 is 23/10. Let's see what this looks like. What do I do first? You could do a couple things first. We could start with the same process that we've always done and start subtracting this. But for simplicity's sake, the book says when you've got these mixed numbers, why don't we turn them all into impropers right away? So I guess we can follow their lead and say 7/3 x minus 6/5 is 23/10. Okay? Now what do? What's that process? Don't do the 7/3 yet. Don't deal with that. Add, right, inverse operation for that 6/5, which really has to be done horizontally. Let's take this opportunity, as long as I got to rewrite this, and I'll just jump this down here. As long as I have to rewrite this, let's change that denominator when I write it up here. So what's the numerator going to become? You see what I'm doing? Numerator 12, because 6 times 2, just like 5 was times 2. Now 23 plus 12 is 35. So 35/10. Almost there. What's my last step? I have 7/3 x equaling 35/10. Could have done some canceling. Maybe we should do that reducing now. 35/10, let's turn that into 7 seconds. That looks a lot nicer. Divided top and bottom by 5. Finally, multiply both sides by the reciprocal to that coefficient of the variable. That's 7/3. Let's get it out of there. Have to do the same to both sides. Ooh, look what turned out nicely. Since we had matching numerators across the equal sign, we can cancel diagonally to get 3/2. 3/2 looks the same simplified as top of page 196. Again, that was example 61.3. If you want to see the way that they explain it, they do it roughly the same way, except they did this canceling ahead of time so that they didn't have to do this down here. And that makes things simpler. Make numbers smaller when you can, as long as you're following the rules. So remember, solving equations in 2 steps means adding or subtracting from that variable side, getting eventually x by itself by eliminating this coefficient in the second step. Right? This was the first step. That's the second step. And you want that 1x. What is 1x? Pick 3 between A and D, please, because these are so important.